Hello guys, welcome back to my channel. And according to the recent statement government, we've slowly started to change our lockdown stage, which is pretty good. And some of you may receive email already from school. So after 2 weeks, year 11, year 12 students and preschool students to go back, and then follow another 2 weeks. I think other year level will go back as well to see if everything works. So let's continue our study. Today I'd like to talk about the integration, or use another word such as anti-differentiation. Okay, please just use my videos as the assist for you understanding for the topics, and I just gonna cover like the most important things from the textbook, and hopefully can help you understand a little bit. So as we said before, differential equation or derivatives is help us to getting the rate of change, right? So the anti-differentiation, or we should say the integral or integration, is they both are helping us to find the area under a graph. Of course, we know how to find the area for square, for triangle, or for parallelogram, because they are they're really good in the good shape. They are not really involved with curve. But once the area involved with curve, such as in this case 9 minus 0.1 x squared, so in such case it's basically quite hard for us to find the exactly area, right? That's why we invent all the math method. The, they just like to invent or like develop our calculus for calculate the exact area. So before that, we just first to learn some estimation skills, right? So if we want to find the area between 2 to 5, we can make some rectangular like R1 to R6. Then we can just use base times height to get each of them the area. Then we add them together. And according to this one, we call them left endpoint estimate, because each of the rectangle, the left endpoint is the exactly value. Okay, they are the accurate one. And then we move a little bit for this part. It's just the estimate error. Okay, so for in this case, our left endpoint estimate is gonna be slightly bigger than the real area, right? And then for the right endpoint estimate, in such case, we just make sure the right is touch the graph. So essentially it means the right top corner is exactly value, and we towards to the left. The left is a bit like the approximation like this. So in such case, for this kind of area over here is our estimate error. So, and in this case, our right endpoint estimation is is slightly less than the real area. And of course, we know the fx, the error is going to bound between my left endpoint estimation and my right endpoint estimation, right? And which one is bigger or which one is larger, we have to consider the fx. If xx decreasing, then this is the case we just talked about. If my fx increasing, which is like this one, so my right endpoint estimate will be larger than my left. Okay, this one just gave us some ideas about before and how we develop our integration. So let's just imaginary I make my rectangular step size, or my base is infinitely small. So I make it like infinitely pieces, then I adding them all together to get, then essentially we get exactly the area we want. Then this we call the definite integral. Okay, and we can make some example by use our year 11 knowledge. Let's just assume this one, the area of triangle base times height 2 times 2, then times half gives me 2. and the integration y3 x minus 1 dx. So I use my year 11 stuff. I know this one will be half x squared, and this one will be my x, and it will be 3 and 1. So I plug in. I got 9 over 2 minus 3 minus half 1, right? So after my calculation, I got 2 9 over 3, sorry, 9 over 2 minus 3 plus half plus 1. So I got this one will be 5. This will be, sorry, 9 over 2 minus 3 and plus half will be 5. The final answer will be 3. Just give me a sec. Okay, now I know where I went wrong, because this one should be minus, then the final answer will be 2 as well. So this one just confirm that our area under the curve is just integral. Okay, we can use this simple example to illustrate my point. So after that, we know what the exact area means, and followed by the later is pretty straightforward. Antidifferentiation, or we call it indefinite integral. So basically, we don't know the upper limit or lower limit. So essentially, we need add arbitrary constant after it, because x squared plus 1, the derivative is 2x, and my x squared plus 100, derivative again is 2x. So if I do the integration, I don't know if they have the c or not, so I have to plus c to give the general solution, and you have to give me the initial condition, then I can tell you what the value say is. Okay, so this one I think you guys learned in year 11, and it's straightforward. You should be familiar with this guy and practice it to know what's antidifferentiation when the r is not -1. Because when r is -1, it essentially gives us the logarithm. Okay, we will talk about it later. And this is 11b for 11c for r not equal 1, followed by the same rule. So it's again, it's antidifferentiation, it's a polynomial. But when my r is -1, that essentially gives us the log, okay, log e. So you should remember that. And another thing is, because we have no idea about ax plus b is greater than 0 or less than 0, so we have to make different case, because inside of log e, which is the domain, my overall must be always greater than 0. Okay, that's why I have to consider if it's positive or negative. Otherwise, you can always make its absolute value. Okay, to then use the initial condition or use other constraint provided by the question to get rid of the absolute value sign. Otherwise, you just need to keep it as in your final answers. Same thing with CAS. You're gonna see over here they give you the x value. Sorry, they give you the absolute values for x, and the ln ln just inside of the CAS. It just means log e. Okay, same thing. So the law of exponential change it's actually covered in our chapter 5, and hopefully this one can refresh memory. We use this one to, model the population growth or some like the sales growth or even like the half-life when my k is negative. Okay, so this one is 11c. For 11d, it's pretty straightforward. It's just like the e to the power of x, the antidifferential for ex. So my derivative of exponential function or ex is just ex. So when I anti-differentiate, again, it's the same thing. Okay, in here is 1 over k is only because of the chain rule. Okay, because let's say my y equals 1 over k e to the power of u, my u equals kx. So the derivative is 1 over k and to the power of u. This one is just the k. So I multiplied them together. I got e to the power of kx, which is essentially this guy. Okay. So the differentiation and anti-differentiation, they are just like the reverse things, like a plus and minus. Okay. So this is the 11D. Okay, I think this is a good point to stop. And for the next one, we're going to discuss more about the theorem of the calculus, or what's meant by the definite integral, and other stuff like what's the sine x anti or what's the cos x anti. Okay, hopefully my video is helpful, and see you guys for the next videos. Bye bye.